Let's discuss problem 4. If Vx is equal to minus 12, this means this voltage is given, which is voltage across 2 ohm, and polarity is in this orientation. Find Vs, that is the source voltage, and VBA, which means that the voltage between terminal B and A. This means that B is at high potential and A is at low potential. I is flowing from A to B. It is already mentioned, so I'll just highlight it. So the hint given is use KVL. So I'll use KVL. So as I discussed before, KVL implies that whenever I see KVL, I have to assume a loop. So since this is a single loop, it means that the current path is not changing. So current is same in all the elements. So I'll just also bring that loop the current outside here just to emphasize that. So that current is I. It's already mentioned here. So now you can see that in this problem the voltage, I need to add the voltages. So this voltage is known, this is actually given. Vs, we have to find it, and there is no polarity here. So the first thing which I have to do is use passive sign convention. So first I'll use passive sign convention, which says I'll just highlight this. As was mentioned in the textbook, so if you have any element, and if it is a passive element, which means the current I is flowing, so I is given now, so you cannot choose the polarity at your own. You have to follow the passive sign convention, which says that if the current is flowing, so definitely the current is flowing from high potential to low, if this is a passive element, because it is analogous to gravitational potential, that if a person is falling, so it means that he has jumped from high potential or high altitude to a lower altitude. So because they both are analogous, so that's why we are assuming that this current is actually positive charge, because it will relate the charge with the person, and gravity, so gravitational potential with the electric potential, and also the change in height or change in the altitude would be similar to change in potential, electric potential. So now I have to apply first the passive sign convention, which says that if the current is flowing and it is a passive element, so it must flow from high potential to low. So you cannot choose this direction, sorry, this polarity at your own if the current is given. If you have selected the voltage, for example, let's suppose if this is a passive element, and if I have chosen the polarity in this direction, so the current must flow in this direction, positive current, and if this is positive voltage. So I have to give a name to this voltage. So I'll just say V1. This is another, its polarity is given. I can bring that polarity over here, plus minus Vx, and since this one is not given, so if positive charge is coming here, so it will flow from high to low. This is plus, this is minus, and I'll give it some other name which is already used, so maybe V2. Now I have assigned all the elements have the polarities and they have the variables, so now I can use KVL. KVL can be, you can start from anywhere. For example, if I start from this low terminal here, so I hit positive charges coming, hitting a positive terminal, plus V2, minus hitting a minus terminal, so the value 4, plus V1, plus Vs, plus Vx is equal to 0. It is a big mess because we have introduced many variables, and this is a one equation. Since this is a single loop, so I cannot bring the other equations, so I have to think. It should not be unthoughtful here. We should use some other strategy here, which should be that I'll directly apply the Ohm's law. I can also follow this step here, Okay, I'll do it further here. Otherwise, you could have done without assuming these new unknowns and just directly write the Ohm's law. So I will do it here. This V2 is here, so this is equal to Ohm. So this is a passive element. So the Ohm's law would be, for example, if this is the voltage here, this is the current. So Ohm's law is V is equal to plus IR. If it does not follow the passive sign convention, then the Ohm's law will have a negative sign. Regardless if the sign of the current is positive or negative, or even the sign of the, as it is given here, Vx is a negative voltage, so will not take care of that. The passive sign convention will take care of itself. So let's start here again. Ohm's law here it is following a passive sign convention. So Ohm's law is IR. I is already given. I is assumed. So R is 1. So I into 1 is actually I. So this is now I volts instead of amperes. Minus 4 plus V1, again apply the Ohm's law, I into 1, which is I, plus Vs, that is the unknown, plus Vx is actually given, it is minus 12, so I can write plus minus 12 is equal to 0. Now it's much better now because I have two unknowns now instead of more than two unknowns in the equation A instead of in equation B. So we have reduced the unknowns. Now if we have to, because this is a two unknown and one equation, I have to rely on some other strategy, and that is that since I know this voltage and this is the resistance, then the Ohm law, if I have one equation and one unknown, I can find it because Vx is given, the voltage which is here is given to us, a resistance is given to us, so the unknown is current. So I can find that current from this given data here and then insert the currents here. Then this is one equation and one unknown. So I'll apply Ohm's law here. So Vx is equal to, the current is a passive element hitting a positive terminal, so I into R is 2 ohms, I into 2, Vx is given, it's minus 12 is equal to 2I, and this implies that I is equal to minus 6. So this I is equal to minus 6, I will insert here minus 6 minus 4 minus 6 plus Vs minus 12 is equal to 0. So this is 12, 24 and 4, 28, and Vs is equal to 28 volts. So now the first unknown, which was our goal to find, Vs, and that we have found in this step here. Now the second step is that I have to find VBA. So I'll make this orientation over here. This terminal is terminal A. The other terminal which is here is B. Current I is flowing in this direction. And now if I use VAB, it would mean that A is at high potential, B is at low potential. But if I say this voltage is VBA, then B would be at high potential and A at low potential. And we know the relationship that if we flip the polarity as we have done here, then one of them will have a negative sign. So it means that I can find VAB or VBA, whichever I like, and then I can find the other one. In this case, because passive sign convention is V1 is in this case is VAB, because V1 variable has a positive terminal which is connected to A and negative terminal connected to B. So it means that V1 is same as VAB, and I have to find VBA. So it means that V1 can be found easily, which is already done here. Because V1 is -6, I can see directly here because I substituted here the Ohm's law, and I is already -6. So from this one and this one, but I can do again over here. V1 is same as VAB, and this is equal to Ohm's law, I into this R, which is I into 1, which is -6 into 1, and this is VAB is equal to -6 volts. Since VAB is in the VBA is the negative of this one, so VBA, which was actually our goal to find, is negative of VAB, and that is actually -6, and so negative of -6 is +6. So VBA is equal to 6 volts. So that is how we have to do this problem. So the main thing was to know the passive element, how to apply Ohm's law across a passive element, and also the passive sign convention. And the passive sign convention, I will repeat here, that we cannot assign independently the current and voltages. And I will repeat once again. If this is a passive element, if I have assumed current, I cannot do the voltage polarity independently. So this would definitely be plus, and this would definitely be minus, and some variable is given for the voltage value. And suppose I have chosen the polarity first, then I cannot do independently the current direction. The current direction must follow the passive element, that is current should hit a positive terminal, or if the current, so that is, so to speak, it says that if positive charge is flowing, so it means that across through a passive element, so it means that it is flowing from high to low. That is analogous to if a person is flying in air without any wings or any parachute. So it is obvious that the person is falling downwards. So this should be from high altitude to a lower altitude. So that is already this is built in this passive sign convention.